Welcome back, everyone. I've used a bit of origami paper in some of these explanations here, and we're on to volume, and we're looking at these kind of shapes here. This was once a flat piece of origami paper. It's been folded and turned into a cube. I really like making these things, and I really like using them as a teaching tool to think about volume. And we often say cubic units, like cubic centimeters, cubic meters, cubic kilometers, if we're talking about probably on the scale of how much water's in the ocean, for example. There's the kind of thing, and I'll probably get you to construct one of these for yourself during this time, so you can get a real sort of feel for what's going on here. So when I'm thinking about volume, I'm thinking about how many of these little cubes can stack inside a shape. So it's a real three-dimensional thing. I've got a few tips for you too, because I see a lot of those perspective drawings in 3 dimensions, and I'm not really good at doing those drawings, so I've got a few shortcut tips for you as well. And there's other things that we need to be aware of, like we can make these with paper as well. Some of the questions dealing with these sort of they're boxy type questions, I get it, but you look at it, some of the questions are set up, how much does a box like this hold, and questions like that. So maybe it's a good idea to fold one of these and have one of these in front of us while we do that work. And then the other thing to think about is that some of the other questions look at I know there's a few questions there that they're sort of looking at, you've got a box and you've got a space enclosed in there, and the box has a certain thickness to it. So that affects how much volume is in here. If they're planks of wood, for example, then that reduces the internal space inside this box. It's not necessarily working out and crunching all the outside dimensions of what you see on the outside. It's actually thinking about the internal space inside the box. So I'll get behind the light board, and there's a bit I can show you here just to help you through these style of questions. Okay. In this video, we're looking at volume, and we're thinking about cubic units. So what does that look like? We need to write, if we're working in millimeters, we need to write millimeters cubed, centimeters cubed, meters cubed, and kilometers cubed. Now, there might be some questions asking us to convert to liters. I'm not sure. But if that happens, we need to remember that 1 cubic meter is equal to 1,000 liters. And another good one to remember is 1 cubic centimeter is equal to 1 milliliter. So I'm not sure. There might be some questions in there asking for those kind of conversions. But mostly I think they're just going to be the kind of boxy, grindy, crunchy questions. So next tip. I'm not really good at 3-dimensional drawings, but I know when we're working in 3 dimensions, we need to know 3 things. Okay, we need to know the length, the width, and the height. So I'm just picturing one corner of that cube or that box, and I need the 3 bits of information. So my sketch was sort of reduced down to 3 lines, if you like, and that's what I tend to work with. So we've got a formula here. We might write V for volume equals length, width, height. Now, in some sense, if we want to make a cube here and put some numbers on it, 3, 2, and 4, for example, mathematically crunching the numbers, it doesn't really matter what order you slot them in, if that's all we're interested in. So 3 times 2 is 6, times 4 is 24. So the volume of this, I'm just going to put meters there. So we might be dealing with 24 meters cubed, and that would be our answer. And like I've said before, if you didn't know what the units were and that wasn't given, and you didn't know that, you're always welcome to write units cubed if and when they specify that you must include the units and you don't know them. So there's a little get out of jail free type situation that you can use. So I've said all that and I've crunched the numbers and I've just treated them like numbers, but I think it's worth pointing out to you that if we use these numbers here again, the dimensions of these cubes are very different if we start swapping the numbers around and thinking of them as different shaped boxes, for example. So we might have something like that. And if we're thinking about the dimensions and trying to pack them into something, then those considerations would be really, really important. So I guess that's a caveat on what I was saying there about the order. Sometimes it doesn't matter, sometimes it does, especially when we're thinking about the dimensions of these cubes. So you'll end up in situations here with the work. Here we've got some kind of cube, and for example they might give you some of the information and tell you that the volume, something we don't know up there, the volume is equal to 56 centimeters cubed, and it becomes your job to work out what the missing dimension is. Okay, and we can go about guessing. I'm thinking 4 times 2 times something, well that turns into 8 times something is equal to 56, and so that something has to be equal to 7 centimeters if that's what we're working in. Okay, that's one way to work it out. We could take the formula and we could write it out, and then we could rearrange it to solve for, we don't know the height, for example, so we might rearrange that and make it look like that. Substitute in the numbers, 56 divided by 4 times 2 is 8, and we can get to the same answer there. H is equal to 7. Okay. I know that a lot of people aren't really strong with division, so, and they're not really strong with rearranging formulas either, by the way. So that might not be the road that you go down, but you can certainly get into the first way I taught you about and get into that guessing game where you are trying to work out the value of that number. So I'm just going to take a moment here to work on another question, and again a box type question, and we've got a large box here whose dimensions are 30 by 30 by 20, and we're talking centimeters here. So that's the box, that's a big box, and then in one of these questions we're given the dimensions of a matchbox. And those dimensions were 5 centimeters by 3 centimeters by 2 centimeters. So, and the question was, how many of these matchboxes fit inside the box? And there's a couple of ways you can go about this, to be honest with you. You could go along here and work out the volume of this box, crunch the numbers. 30 by 20 by 30. I'm going to do something here that might help you out a little bit. I set it up like this. Sometimes I think about these questions as a game of zeros. This is multiplying by 10 here, and that's the same thing as 1,000. So the real work is here, and that is 3 times 3 is 9 times 2 is 18. So we're at 18,000 centimeters cubed for our answer there. And we can work out the volume of this guy here, 5 times 2 times 3, and we're at 30 centimeters cubed. So to work out the final answer here, we've got to ask ourselves, we've got 18,000, how many 30 cubic centimeters fit in here? So we're going to arrive at our answer perhaps this way. We need to do a division calculation. I'm going to set it up like this because I'm going to cross off some zeros, and I see that 3 goes in here once and goes in here 6. So my answer is 600 matchboxes. Okay. That's just treating things as numbers. So I've got another way, I guess, another way to think about it that might help us understand and double check, because I kind of often think about the dimensions as being important. And so let's draw out that box again. Let's draw it a little bit bigger. Let's label it as 30, 30 and 20 high. So we're told that each matchbox is 5 by 3 by 2. And if we think about how many 5s are in here, I'm not going to draw them all, but I can see we can make 6 rows. And then I think about this dimension here, the width. And I'm thinking about how many 3 centimeters I can stack each box along here. It takes up 3 centimeters, and I'm going to get 10 of those. And then I'm thinking about how many different layers, because the matchbox is 2 centimeters high. And so I've got 20 centimeters to work with. Each matchbox is only 2 centimeters, so I've got another 10 there. And when I crunch my numbers here, I'm at 6 times 10 times 10 is 600 matchboxes that I can fit in here. Okay, so that works out kind of nice for us. I've got one final way that maybe, just maybe, it's worth sharing this, because what I see sometimes is that we deal with really large numbers here, and what I'm often thinking about, I come back to this type of arrangement here, knowing that I'm going to do a division. And why don't I write this out here times 1,000? And I'm hoping I've got enough room here. And each matchbox is 5 by 2 by 3. So I'm going to set this up like this, 3 by 2 by 5. And watch what happens here when I just think about factors and cancelling down. 5 goes in here once, and 5 goes into 1,200 times. So hopefully you can see now my calculation, final calculation after all this cancelling down, is kind of simple. It's 3 times 200, and the answer to that is 600. So they're all things to think about as you're working and you're doing this work on volume. I've offered you a couple of different ways to work here and a couple of different ways to think. All right, good luck. There's another question here, and I spoke about it in the introduction to this video here, thinking about the inside of a box, right? So here's an interesting question that you'll come across while you're working through your textbook here. We've got a wooden box, and the dimensions of this box, it's a 20 by 20 by 20 cube, and it's made of timber, and the wood is, they say in the question here, the wood is 2 centimeters thick. So what I'm picturing is getting a tape measure or something, or a ruler, and measuring on the inside of the box. If this is the outside here, and these are the outside dimensions, we need to think about what the inside of the box looks like. And if we take 2 centimeters off each end for the thickness, then that's going to affect the inside dimensions of the box, and I think they'll all be 16 centimeters on the inside. So it's a good question because it forces us to think this way, and they want to know the volume of the air or something that's on the inside of the box. So this is what we're left with, and the volume will be equal to, or the lengths are all the same, so that's going to be 16 cubed, and that's what we need to work out. So I'm just quickly going to work that out now, just using this model here. And what am I got? I'm at 256, and now I need to multiply that by 16 again, and just working here for the exercise of it, that's times 10 plus 6 lots of 36, carry the 3, 6 times 5 is 30, and 33, sorry, when I add that up, and then I'm at 12, add the 3 here, and I need to add those together. And what do I get? 90, carry the 0, 496 centimeters cubed would be my final answer there. So a really good question to get you thinking